Hey there, we will be discussing the Palindrome Linked List interview question on LeetCode. To fully understand the material, it is recommended that you review the previous tutorial on reversing a linked list. So let's take a quick look at the description of our problem. Given the head of a singly linked list, return true if it is a palindrome or false otherwise. Follow-up. Could you do it in big O of n time and constant time space? The reason behind this is that they don't want you using a bunch of for loops and brute force to solve this problem. First of all, according to Wikipedia, a palindrome is a word, number, phrase, or sequence of symbols that reads the same backwards as forwards, such as the words madame or race car. So in the example 2, if we reverse this list, it will be 2-1, and 2-1 is not the same as 1-2. Then the algorithm output is false, it is not a palindrome. But in the example 1, the list is 1, 2, 2, 1 reversed. Is identical to its normal version, then yes, it's a palindrome. Without further ado, let's take a look at the algorithm to solve this problem. In order to solve this problem in a constant space complexity, we could use a strategy using two pointers, two list node pointers. These two pointers are usually called slow and fast pointers, but the difference between them is that the fast one is going to jump 2 slots every iteration. The so-called slow pointer is going to iterate through the list, visiting one element at a time. If you think it through, you're going to soon realize that when the fast pointer gets to the end of the list, no matter the size of the list, the slow pointer is going to be at the middle of the list. If we have the slow pointer pointing to one half of the list, we can reverse it and check whether or not every item of both halves are equal. We're going to point the fast pointer to head again, so we're going to point it to the start. Now we compare. If the two halves are identical, we have a palindrome linked list, ladies and gentlemen. So let's take a look at our code, shall we? We're going to start with a base case, almost the same base case we've used for the reverse linked list problem, but we return a boolean instead of head. If the value of head is null, or the subsequent value of head is null, return true. A list with no elements or a list with a single element, when reversed, is the same as the original list. We're going to create two list node variables pointing to head, one being the slow pointer and the other the fast pointer. Since the fast pointer is going to get to the end of the list quickly, we iterate through the list while fast or fast.next equals to null. The slow pointer is going to iterate one element at a time, so it will always going to receive the value of the next element. The fast pointer, in the other hand, is going to jump 2 elements at a time, so the next of the next element. Now that we have our slow pointer pointing to the middle of the list, we're going to do two things. First, we're going to reverse the slow list, the one pointing to the second half. Second, we're going to set the fast list to head, to the beginning of the original list. Let's create the method that will reverse our linked list. The method is going to return a list node, and it's going to receive a list node as its parameter. We're going to use a previous node reference, and we're going to set it to null. Then, while the value of head is not null, so while the list node doesn't reach its end, next node is going to receive head.next. Head.next is going to point to previous node. Previous node is going to point to head. And finally, head is going to point to next node. That's as simple as it gets. After we iterate through the entire list, we return the previous node. I strongly suggest you watch my previous video on reversing a linked list if you are having difficulty understanding this concept. Now back to our isPalindrome method, we're going to iterate through the slow list. We compare the current value of the slow and fast pointers. If they're equal, we move both pointers to the next element and repeat the process until we reach the end of the loop. It becomes clear that if all values are equal, we have a palindrome. Otherwise, we simply return false. If all checks have been successful, the only remaining step is to return true, as the input list has been confirmed as a palindrome. We run the algorithm and submit the solution. If you enjoyed the video, subscribe to my channel for more tech content. Thanks for watching. Bye bye.